Subtracting fractions. Okay, so before we begin, the first thing that we always need to remember before we do any subtracting of fractions is that our denominators must be the same. If our denominators are not the same, we can't actually do the math. So just a reminder, what is our denominator? Our denominator is the number at the bottom of the fraction, and then we've got our numerator, which is the number on top of the fraction. So let's rewrite this to get started. Just select here a color, perfect, we're all set. So we're going to rewrite 3 over 5 minus 2 over 5. Now we notice in this question that both denominators are the same, which means we can actually go ahead and start doing the math. So we're gonna put the 5 at the bottom because they both have the same denominator of 5, therefore our denominator will be 5, and we can actually subtract, and so we moved our numerator, so the numbers from the top of the fractions to the top of this one right here, so that we can go ahead and do our subtraction. So 3 minus 2 is 1, and the 5 stays the same. And so that's one example. Okay, so here we have another example. We've got 7 over 4 minus 5 over 12. And so right away we notice something. We notice that our denominators are actually different. And so we said we can't start subtracting until we make our denominators the same. So let's make these denominators the same. And how do we do that? Okay, we take a look at the denominators and we ask ourselves, is there a number in the 4 time table and a number in the 12 table that can give us the same result? Okay, so is there something that we can multiply by 4 that will give us a number that if we multiply 12 by something will also give us that number? So is there a number in common in both timetables? And so we know that the 12 is actually a number that they both have in common. And how does that work? Okay, well, this is how it works. Let's write it down right here. Because 4 times 3 equals 12. And 12 times 1 equals 12. So we know that in the 12 times table, we get a 12, and in the 4 times table we can also get a 12, and so they're both a common denominator. And so therefore, if we actually multiply the 4 times this number 3, we can end up with the same denominator. So now we know that 12 will be the common denominator for both fractions, for this fraction and for this fraction. Okay, so we start looking at the first fraction. So what do we need to do to the 4 so that it becomes 12? Well, we multiply that by 3. And the rule of thumb says that whatever we do to the bottom, we also need to do to the top. So that means we're also going to multiply that number by 3. Now we look at the next fraction. What do we need to multiply the 12 to in order to give us 12? Well, 1. And whatever we do to the bottom, we do to the top. And so that becomes 21 over 12. How? Because we multiply 7 times 3 is 21, 4 times 3 is 12, minus 5 times 1, which is 5, and 12 times 1, which is 12. So now we do have a common denominator. They both have the same denominator. So we can go ahead and do our subtraction. And so to do that, we have the 12 at the bottom, and now we're gonna grab the 21 minus the 5, which gives us 16 over 12. And so that would be our answer. Now, there's one more thing, is sometimes we may be asked to simplify or to reduce to its lowest term. And so what does that mean? It means that we can still reduce the 16 over 12 further. So I'm going to bring it over here. So we've got our 16 over 12. And how can we reduce this even further? Well, what that means is that there's got to be a timetable that gives us both 16 and gives us 12. And so in this case, it's the 4 times table. How do we know? Because the 4 times 4 equals 16 and 4 times 3 equals 12. So if we actually divide these two numbers by 4, because we're looking at the 4 time table, we can reduce this further to 4 and 3, because 4 times 4 equals 16, 4 times 3 equals 12. So our final answer is 4/3. Okay, so here we have another question. We've got 3/5 minus 1/3. So what did we say is the first thing we do when we're subtracting or adding fractions is we take a look at the denominator. The denominator must be the same before we subtract. So in this case, it's not the same. So our first step will be to make the denominators the same. Okay, so let me grab my little pen. Okay, so we've got 3/5 minus 1/3. So we look at the denominators and we ask ourselves, what number in the 5 time table and in the 3 time table is the same? So what number do we find in the 5 time table that we can also find in the 3 time table? And that number is 15, because 5 times 3 equals 15 and 3 times 5 equals 15, which is the same, if you notice, as multiplying these numbers to each other. When you multiply the denominators to each other, you're always going to get a common denominator. So that will always work for you. Okay, so now we can go ahead and do our next step, which is making sure that whatever we do to the bottom now, we do to the top. We know what our common denominator is going to be. We're going to be using 15 because we see 15 in both the 5 time table and in the 3 time table. But now we got to make sure that we apply that to the top as well. So we are multiplying the 5 times 3 to get 15. And so that means we got to multiply the top here by 3. In this case, the 3 we're going to multiply by 5 to get 15, which means we're going to multiply the top by 5. Okay, so let's write our new equation. It's going to be 9/15, because 3 times 3 is 9 and 5 times 3 is 15, minus 5 times 5/15, because 5 times 1 is 5, or 1 times 5 is 5, and 3 times 5 is 15. So now we can go ahead and start subtracting. So the bottom will be the denominator that we have already, which is our common denominator, and the top will be our numerators that we can start subtracting. And so 9 minus 5 equals 4, and 15 is already our denominator. Okay, let's try one last example. So we've got 3/4 minus 2/10. So we said the first thing we're going to look at is, do we have the same denominator? And in this case, we notice, no, we don't have the same denominator. That means our first step will be to make these fractions both have the same denominator. So let's work with that one. So let me just get my little pen here. All right, so let's rewrite our question. So we've got 3/4 minus 2/10. Okay, so do we have in the table of 4 a number that is also found in the 10 time table? So is there a number in the 4 time table that is also found in the 10 time table? That's what we need to remember. And the answer is yes, it's 40. And how do we know that? Because 4 times 10 equals 40, and 10 times 4 equals 40, which, as I had mentioned before, is the same thing as multiplying these two together. Okay, so let's go to the next step. So we said, okay, whatever we're going to do to the bottom, we're also going to do to the top. So let's get our other color so that we can show what we're doing. Okay, so let's take a look at our 4. That'll be our first number. So what are we going to multiply the 4 by in order to get 40? Well, we're going to multiply this by 10, which means that we're also going to multiply the top by 10. And what are we going to do to the 10 so that we can end up with a 40? Well, we're going to multiply the 10 by 4, and that means that we're also going to multiply the top by 4. So let's rewrite our fractions. So that means that we've got 30 at the top here because 3 times 10 is 30, and we've got 40 at the bottom minus, and we have 8 at the top here, and we've got 40 at the bottom. So now we're ready to subtract. We've got here then our denominator will be 40, and we can now get our 30 minus 8, which is the same thing as 30 minus 8 is 22. So when we subtract 8 from 30, we've got 22, and our denominator will be the same. So now we have 22 over 40. Are we done? No, we're not done. And the reason we're not done is because we can reduce this further. There is a number that we can divide the 22 by and the 40 by. So there's a number that when you look at the timetable of that number, we will find 22 and we will find 40. And that is the 2 timetable. If we divide those two numbers by 2, we notice that we can actually reduce it further. 22 is divided by 2, so 2 times 11 equals 22, and 2 times 20 equals 40. So this is the answer that we have. So when we are reducing fractions, and I do have another video on how to reduce fractions so I get some practice on doing that, what we need to find is a number that will fit into both of these numbers to reduce it further. We found that the number that we could use was 2, because 22 can be divided by the 2, or 40 can be divided by the 2. Another way to say it is 2 times something equals 22, and 2 times something else equals 40. And this is that something and something else. 2 times 11 equals 22, and 2 times 20 equals 40. So our furthest reduction, so when we have to simplify our answer or reduce it to the lowest term, the final answer is 11 over 20.